Hello students, straight back again. Today we get to look at section 7.4, metallic bonds and the properties of metals. This section, our objectives are: you get to describe a metallic bond, you get to relate the electron C model to physical properties of metals. This electron C model, a very key idea for why metals have the properties they do, and we get to look a little at alloys, defining them, categorizing them. Old property, physical property, review vocab, characteristic of matter, it can be observed or measured without altering the sample's composition. New vocab, electron C model, delocalized electron, metallic bond, alloy. We'll get definitions for those as we move through the section. Our main ideas: metals form crystal lattice, can be modeled as cations surrounded by a sea of freely moving valence electrons. Metals not ionic, but share a lot of properties with ionic compounds. Properties of ionic compounds and metals, very similar. Metals, both metals and ionic compounds are going to form lattices where 8 to 12 other atoms closely surround each metal atom. And as these things in the lattice, the outer energy levels overlap, and this electron C model proposes that metal atoms in a metallic solid contribute their valence electrons to form a sea of electrons. Runs here, I'll call these, rather than valence electrons, we'll call them free electrons. Electrons are free electrons to move around, called delocalized electrons. Here's a little diagram of what this looks like. We got the metal cations, and then the sea of electrons just all spread out through there. So the metallic bond, the attraction of a metallic cation for its delocalized electrons. Boiling points significantly higher than the melting points because of the energy required to separate the atoms. When they're in the liquid state, the atoms are still close together. As they go to boiling, to the gaseous state, they spread apart a lot. It takes a lot more energy, so much higher boiling points, such as for lithium here, 180 for the melting point, but over 1,000 degrees for the boiling point. Now, some of the properties we've talked about before: metals are malleable, they can be hammered in sheets, they're ductile because they can be drawn into wires. As we change their shape, they really just still have the atoms all close together, but we can move them around a little, and we still have the electron sea of electrons moving around. So very malleable, very ductile. And these mobile electrons, the free electrons, make metals very good conductors of electricity and heat. So the number of free or delocalized electrons affects the hardness and strength. More electrons, more hardness, more strength. Less electrons, less. Alloy. mixture of elements that has metallic properties. So some examples: stainless steel, brass, cast iron. The properties of the alloys differ from the elements they contain, which is in steel, we add other stuff into it to change the properties of iron. So steel always contain iron, but when you add carbon, other compounds to it, or elements to it, makes it stronger than iron. They make it less rust, make it more rust resistant than iron. A lot of different things can happen. Here's a chart with a whole bunch of different alloys and what they're made up of, and some uses for them. Just brass, nice common alloy used in plumbing, hardware, lighting. Most made of copper and zinc. In various ratios depending on what you're going to do it. So copper can range anywhere from 67 to 90%, zinc from 10% to 33%. Got two different kinds of alloys: substitutional alloys and interstitial alloys. Substitution alloys, when in the major metal or element in there, they're replaced by atoms or replaced by atoms of similar atomic structure. Interstitial, when small holes in a metallic crystal are filled with smaller atoms. One's more replacing, one's filling in with the holes. So interstitial, they might have some atoms represented here. Boom, boom. And then the holes are filled in with smaller atoms, kind of act like glue. In a substitutional, something is just replaced with another one. So substitutional, so this one's interstitial, substitutional. Again, we got the same thing going on. But then in a substitutional, comes in and replaces some of these with something of similar size. So this one might be replaced by a different one. Might be replaced. Get some different attractions going on, changing the properties. And a couple review questions. The attraction between a metallic nuclei and delocalized electrons forms a metallic bond. That was just our definition for metallic bond. And definition for ductile allows it to be drawn into wires. So that takes care of a brief overview on section 7.4. That's all for now. Till next time.